Good afternoon, everyone. Hi. I decided to take this to make a short video here to show you how you can use DBeaver. Since starting from next week with week 4, you will have to use it to experiment a little bit with the SQL language, and it will be like this for the next 3 or 4 lessons. So let me first tell you what you should do when you're going through the material of week 4. When you're going through the material, you will find several places, several slides with code in it. Now, this code, I would not suggest you to try and put it as it is within DBeaver. Just use it as a, as a guidance while you're going through the slides to understand the different comments. What I want to do instead is to show you directly in DBeaver how you can use SQL to do exactly the same things which are explained on these slides. So again, go through the slides, understand the code, and then follow this clip to see how you can replicate these steps with different tables, different data directly in DBeaver by yourself to start practicing a bit. In addition to this clip, I'm also going to give you the whole script. I will upload it on Moodle and let you know where to find it. So one step at a time, we go into DBeaver. It's this one here. So once you have installed the client and you open the client, DBeaver will look like this. This is the dark mode. Maybe in your case, it will look brighter, but you can always change it, of course, through the options. Now, the very first thing that you want to do is to connect to a DBMS. And that can be done by going here to this icon over here, click on it and choose the DBMS you want to connect to. There are different options. If you have followed my instructions and you have installed MariaDB, you can connect to your MariaDB data server. But these exercises will be doing it using SQLite, which is a much easier approach because, as I explained to you already, SQLite is embedded within DBeaver, so you don't really have to install anything else. So I'm going to choose SQLite. When it opens, it asks you to either find an existing file that represents a connection to a database or to create a new one. You can just create a new one. At this point, you will need to choose where to save it. So you can choose any location on your computer, doesn't really matter. Wherever you choose to put it, just give it a name. You could call it, for example, week 4 SQLite and click save. This will create a file on your machine in that location. If you want, you can check the connection and test the connections here. So you can click test connection. And if all goes fine, then you will see this message connected. You click OK and you click finish. And that's all. Now you are connected to a DBMS, an SQLite DBMS, and you also created a database already called week 4 SQLite. If you click on this icon over here, you can actually see that there are folders for showing the tables, the views, indexes, and other things. Right now, the tables are, of course, empty. So now we're going to work on this database. If you right-click on the name of the database, you can go on SQL Editor and then click on Open SQL Script. Now, if you type here now, this is where we are going to type our instructions. Now, I have prepared a script, which, as I said, I'm going to actually upload for you on Moodle. But I'm going to go now through the script step by step with you to comment on what is happening as we proceed. There are a few things, especially at the beginning, that we are going to do and that I don't need you to remember or to know about, but these are needed for the remaining part of the script. So we'll start with something like this. This is the beginning of the script. And this is one of the things that I don't really care about you remembering or knowing about. I just want you to be aware of what this does. So once you have read the week 4 material, you will have understood more about foreign key constraints. This was already also covered in week 3, by the way. So you will know that if I have 2 tables, table 1 referring table 2, then the foreign key can only have values which exist in table 2, or else it may have a null value. Now, SQLite works differently from other DBMS. By default, SQLite does not enforce any constraint on the foreign key. So because I actually want you to work in a normal condition, we are going to enable this constraint by using this instruction. So how does it work in DBeaver if I want to run a single instruction? You see there are some icons here. The first one says execute SQL query, and it's like pressing Control Enter. The third one is executing the entire script. So if I have several commands here, it will run through all of them. Right now, we are going to only use the first one and run one command at a time. And to make sure that it runs the one that we want, we are going to select it every time. So we are going to select the instruction, and then I'm going to click Control Enter. Or alternatively, you can just click this one. If you do this, it's just executing this instruction. And from now on, the constraint on the foreign keys are active for this database. That's all. Now, as a very first step, something that you have learned now if you went through the material is how to create a table. So the very first thing I want to do with you is to create a table for readers. Now, there is something else that is different in SQLite compared to other DBMS. SQLite does not have the concept of schema that you have learned about in the slides. So instead of using a notation like this one, LTS.reader, where LTS will be our schema, because SQLite doesn't understand schema, we just give this name for the table. So we're going to say create a table if it does not exist already, and give it the name LTS reader. And then the table has certain properties, an email, which is the primary key, first name, middle name. These are all things that I think you can understand by yourself. So I select all of this and I run it. You see that it's successful. Now, if you want to see it here, you need to refresh this view. So you can right click and click refresh. Now you can see that the table is actually there and it has specific columns. Very nice. Now that we have a table, we can read from the table. And you know from the slides that to read from the table, you need to use a select command. Select everything from the readers, where everything means all the attributes. So if I run this one, you can see here that right now the table is empty. So I don't have any record. Well, then we can start inserting some records. So let's start with these two. I'm copy pasting them from the script. So I'm inserting first one reader with this email address, this name, no middle name, last name, and so on and so forth. And I'm inserting a second one. We'll do it in two steps. First this one, Control Enter. Then this one, Control Enter. I have now inserted two records. So if you try to, again, read from the table by doing this, right? So now you can see that there are two records in your table, as expected. Now let's try to cause an error here. Let's try to insert a new record, which has a problem because it has the same primary key as one that we have already inserted. Remember from here, the email is a primary key. So if we try to insert it one more time, we are going to get an error from SQLite saying that the primary key constraint failed. And this is to be expected. So this is good. It's working as we would want it to work. Now, what if I don't want to retrieve all my attributes, but I want to retrieve only, let's say, sorry, not all my records. I just want to retrieve those records in which the first name is Luca. So instead of having two rows, when I run this one, now I put a condition where first name equals Luca. I select this command, I run it. And as you can see, only the first row is now retrieved. Again, you have learned this in the slides. Now, I also want you to notice something else. Different DBMS handle differently the case sensitivity. When you create a database, you can actually choose whether it is case sensitive or case insensitive. And SQLite by default is case sensitive. So if I'm asking to find all the rows in which first name is Luca, but written in this way, let's try to run this one. You see that I don't retrieve anything because this name is not the same as this one. So pay attention to this because it could cause some problems if you don't run queries with the correct case. Now, let's also experiment with something else. What if I don't want to retrieve all of these columns? What if I want to project some of the attributes in my result set? Well, you have seen in the slides, you can do it by doing this, selecting the attributes that you want to see. So I do this, I run my query, And this time I only retrieve these two columns, first name and last name. Let's continue. If I'm not happy with the way these column names look like, I can change them. I can use aliases. To use aliases, I do something like this. I say that I want the column first name, and I want this column to be reported with this name. And I want the last name column reported with this name. So if I do it like this now, and I run it, now the column names are the ones that I want. So I'm still projecting only those two attributes, but I decide which name to give to the columns. I can also use aliases for the table name. So I can say that only for the time in which this command runs, the table named LTS reader is temporarily named also U. So I can actually use U dot first name if I want to retrieve that column, or U dot last name. I could have chosen any other name here, or as long as I use it properly there as well. So we can say that this is my alias, I run it, and I get exactly the same result. Okay, now I didn't put an alias for the column, so the names are back to the first name and last name. Okay, hope it's all clear until this point. Now I'm about to create a second table. I call this table genre. And this is a very simple table. You see, it only has one attribute, which is the primary key. So let's create this table. Sorry, this one. Create it. If you refresh here now, you will see that there is also a genre table there. And we can, of course, insert some data. Now look at this other way to insert data. I'm inserting multiple values at once. This is one record, another record, another record, and another record. So these are the different type of books that we have in our system. I insert them. And now if I select again, every time that I'm running the command, I'm actually running Control Enter. Alternatively, you can click on this icon, Control Enter, and you see here our nice records: novel, romance, mystery, and horror. Okay, the last table we want to build is the book table. This table now has a foreign key. So genre for the book points to the genre in this table. You know that because it's a foreign key, it can either be null or it has to be a value which actually exists in this table. So one of these four. This is generally true for a foreign key. But in this case, because I'm setting it to be not null, null is not a valid value anymore. So I can only insert values which exist in the genre table. So let's experiment a bit with that. Let's start with these two. Let's put these two books. So they have, something is wrong with the way we pasted. Let me just do it like this. Make sure it understands is the correct one. There is an error. There is something. We get it around this. Okay, now it's created. I forgot to create this table before, I believe. Let's try again. Okay, now it's actually working. And we insert another book as well. Sometimes the UI does give a problem, so it keeps marking it as an error, although it's no longer an error because the table now exists. If I rewrite it, it should actually go away. Let's try. It still doesn't recognize it, but the table is there. Now, what happens if we try to insert a null value? In general, a foreign key can be null, but we are imposing it here not to be null. So we are expecting an error from this one. And indeed, there is a not null constraint that is violated in this attempt. So the DBMS doesn't allow you to insert this. Now, let's have a look at our books. Let's just write down a select star from LTS book. So you see you have these two. Somehow the system has still not realized that I have this table in here. The UI doesn't show it as a valid value, but it is a valid value. So don't worry about it. So we have these two records in our table now. Again, we can project some of the some of the attributes here. So we can, for example, choose to have only publication here, and we can start playing with some algebra. I can take the publication here, and I can take the publication year, add 10 years to it, and call it publication year 10 years later. So if I run something like this, I'm getting the two columns with 2020, 2030, 2000, and 2010. So this is to show you how we can actually do algebra on some of the fields of our tables. Now I want to show you how to use another operator, which you have learned about, which is the between operator. I can ask for the books which have a publication year between 2010 and 2030. Now remember, these are the books that we have. So title 1 is from 2020, so it should be returned. And second title, the SBN 2, is from the year 2000, so it should not be retrieved. And indeed, if you run this, only the first one is given back to you. This is how the between operator works. You have also learned about the like operator for doing partial matching with pattern recognition. So in this way, I'm asking for all the readers which have a name, first name, that contains the letters L and U. And again, because if you remember, the first names are either Luca or Anna, the only one that we're going to get with this is this record, which has the first name Luca. The last thing I want to show you, we are going to use now the date of birth, and we filter on the date of birth. So let me first run again the select on all the readers so that we know who do we have inside. Let's just use this one for this. So these are all of our readers. So Luca is from 78 and Anna is from 84. So with this last comment here, I'm asking to retrieve all the readers with the date of birth between the 1st of January 1970 and the 1st of January 1980. So the only one I should get, it's again Luca from 78. So I take this, I run it, and indeed, I'm only getting that record. Okay, as a last step, because we have created some tables, we may want to delete these tables. So in this case, we can use the operator drop table if exists. Now, careful here. I put them in the specific order, the reader, the book, and genre. What you need to be careful of is the deletion of the genre table, because book has a reference to this, has a foreign key that points to genre. So if I try to remove genre, while I still have some books that point to it, the system should give me an error. Let's give it a try. Let's first try to run this one. As you can see, we get an error. Foreign constraint is failing. I first need to delete book because book has a foreign key to genre, and then I can remove genre. Now remember at the beginning when I asked you to do this, if we hadn't done this, then SQLite by default would not have cared about this problem, and it would just have allowed you to delete genre anyway, leaving the DBMS in an inconsistent status. But right now it's forbidding us to do that. So we actually need to go deleting the reader and the books. We can actually do first the book and then the reader. It doesn't matter. They don't have a relation between the two of them. So I'm deleting now the book. And only at this point, I can delete the genre. And now if I refresh my tables here, there's nothing left. Okay, guys, this is all I wanted to show you. I want you to have a full script that you can go through to understand the major things about SQL that you've learned by going through week 4. We are going to do something similar also for the upcoming weeks, but I would really suggest you to go through and to use this as a guidance once you have DBeaver installed. Bye-bye, guys.